Hello everyone! In this video, I will demonstrate how to create an analog clock using the XCGUI graphics library. Let me show a short final demo first. As you can see, the clock needles are moving smoothly. The clock face is stored as a bitmap image, while the hour, minute, and second hands are drawn and rotated dynamically. This approach allows us to create a detailed clock design without redrawing every part of the clock face on every frame. You may be wondering how XCGUI compares with LVGL. LVGL is a complete embedded graphical user interface framework. It provides many ready-made widgets, such as buttons, labels, sliders, menus, charts, and input controls. It also includes a comprehensive styling system, layouts, animations, events, and support for touch screens and other input devices. XCGUI takes a different approach. Instead of providing a complete widget system, XCGUI focuses on lightweight two-dimensional graphics operations. It provides functions for drawing lines, circles, rectangles, bitmaps, and other graphical elements directly onto the display. For a complex touchscreen interface with multiple pages, buttons, menus, and animations, LVGL will normally be the better choice. However, for a smaller embedded application that only needs to display sensor readings, status information, simple graphics, or a custom interface such as this analog clock, XCGUI can be easier to understand and integrate. It gives the developer direct control over how each graphical element is drawn, without requiring the application to follow a widget-based structure. This analog clock is therefore not intended to prove that XCGUI is better than LVGL. Instead, it demonstrates the type of application for which XCGUI was designed: a compact, customizable graphical display for microcontroller projects. In this demonstration, I will show you how the clock face and clock hands are prepared, how the hands are rotated according to the current time, and how the display is updated using XCGUI. Now, let us begin. As with the previous XCGUI demonstration, we will use the Arduino IDE for this project. If you have installed XCGUI in the Arduino IDE, please refer to the previous video and complete the setup first. Before continuing, make sure that you have installed the latest version of the XCGUI library. Now, go to File, select Examples, and then open the XCGUI category. Find the Pico 2W clock demo and open it. This demo requires a Wi-Fi connection, so please update the Wi-Fi SSID and password before compiling the program. As a reminder, this demo works only with the Raspberry Pi Pico 2W because it requires Wi-Fi access. The hardware setup is the same as in the previous video. For this demonstration, I'm using the Gigasitron 2.0-inch TFT LCD display module. You can find more information about this display on the Gigasitron website. Now, select the Raspberry Pi Pico 2W board, and then compile the program. Meanwhile, I will put the board into flashing mode. Oh no, I could not find the port. Let us select UF2 board instead. Okay, the compilation is complete. Now, let us upload the program to the board. Let me hold the LCD facing the camera so that we can see the display as soon as it starts working. Oh no, I could not find the port. Let us select UF2 board instead. Now, let us upload the program again. I heard the USB reconnection sound, which means the upload is complete. The LCD is still off because the board needs some time to connect to the Wi-Fi network and synchronize the time. If the display still does not turn on after about 1 minute, please check your Wi-Fi SSID and password again. Brace! It is working now. The date and time are retrieved from an NTP server. If the displayed time is incorrect, update the time zone setting in the code. Then compile and upload the program again. Now, let me quickly show you how to customize the clock hands and the clock face. All of them are image-based, so you can easily replace them with your own designs. If you have a better idea, you can even use an AI tool to generate your own clock face and needle images. Just make sure that all the generated image files are saved in the same folder as your Arduino sketch. Repeat the same process for all the clock hand images, including the hour, minute, and second hands. Let's take a look at one of the generated bitmap files, such as the minute hand image. The first two values indicate the image width and height. Because the image uses RLE compression, the bitmap rotation function requires a temporary buffer to decompress the image before rotating it. Make sure that this buffer can hold exactly the image width multiplied by the image height. Let us take a closer look at the demonstration. As you can see, the clock animation is already running smoothly. If you need even better performance, you can use uncompressed bitmap images instead of RLE-compressed images, provided that your microcontroller has sufficient flash memory. I hope you have a great day. Please subscribe to the channel if you enjoyed this video.